Ah, eyes, the window into the soul. Blah, 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 blah. Okay, yeah, we've been over this already. And we're gonna rig Mr. Hot Dog's eyes pretty much exactly like we rigged Mr. Squeegee Feet's eyes. So go back and watch that video again if you've forgotten. But we're going to make a couple of improvements, starting where we left off with Mr. Squeegee Feet's eyes. The only thing I've added here is a head bone with the appropriate bones parented to it, which is going to be important for one of the things we're going to do. The first thing we're going to do is address a simple shortcoming in the iRigs user interface. As it is right now, if the user wants to cross the character's eyes, they need to manually rotate the secondary eye bones. That's kind of annoying, especially considering that crossing your eyes a little is actually a common thing to do, for example when you're looking at something near your face. So it would be a good idea to give animators a shortcut to be able to do this easily and quickly. To do that, we're going to use the same technique as we used for the fingers, action constraints. All we need to do is make an animation of the eyes crossing, and link that to the scale of the eye target with an action constraint. So let's make the animation first. Make sure you're on frame 1, and insert keys on both of the eye bones. Then go to frame 11, and cross the eyes, and set keys again. Now go to the action editor, and set the keys to linear interpolation, and name the action something sensible, like eye cross. And remove the action from the armature. And now let's add an action constraint to the left eye from the eye target. We only want the eye target to scale on one axis. In this case, the x-axis probably makes sense, so lock the other two axes. Now let's configure the action constraint. This is exactly the same as with the finger, except the transform channel and action name are different. And now copy the action constraint to the other eye bone. Now if we scale the eye target, the eyes cross. Yay! The other thing that would be nice to improve is to make the eye target optionally stick to the head. In other words, we want a parent-child relationship between the eye target and the head that can be turned on and off at the animator's discretion. This is useful because sometimes, especially in more action-oriented animations, having to keep the eye target moving with the character can be a big pain. So the animator would probably want the target to move with the character's head in that case. But other times, we want the eye target to lock onto something external to the character, in which case having it move with the head would be a big pain. So it would be good to give the animator a choice between those two behaviors, so they can pick the one best suited to the particular animation they're working on. But how can we accomplish this? How can you make a parent-child relationship switchable? So we have two bones here, and let's try to create a switchable parent-child relationship between them. I'll start this by pointing out that one way to look at parent-child relationships is to think of them as the child copying the transforms of the parent, but also being able to move independently within that, right? If all of the transforms are exactly copied, then we get all of the squashing and shearing and scale and location just as we expect from a parent-child relationship. But then the child can also move independently within that. So part of this equation is pretty obvious. We can use a copy transforms constraint to make the bone copy the transforms of the parent. And since it's a constraint, we can use the influence slider to turn it on and off. But unfortunately, when the constraint is active, we can't move the child. So how do we make it movable? Well, the answer, perhaps a little bit amusingly, is parents. Remember that if we want to automate the motion of a bone, but we also want to be able to animate on top of that automation, we just give the bone a parent and put the automation on the parent, right? Well, that applies to this situation as well. Copying the transforms of the switchable parent bone is a form of automation. So all we have to do is give the child a real parent, and then constrain that parent to the switchable parent bone. Let's give it a try. Remove the constraint from the child bone. Now add a new bone to be the intermediate parent. Parent the child to it. And now add the copy transforms constraint to it. Now when we move the switchable parent, the child goes with it. But we can still move the child as well. And if we don't want the child to follow the switchable parent, we just set the constraint's influence to 0. Whenever I need a switchable parent in a rig, this is how I do it. There is another way to do this, via something called a child of constraint, but I find this solution to be more reliable and flexible, and it really only takes a single additional bone, so it's not that complicated. Now we just need to apply this to our iRig. We need to add a bone to be the intermediate parent, and let's name it MCH iTarget parent. Make the iTarget the child of this new bone, and now constrain the new bone to the head. Of course, this makes the iTarget move away from its default position. To fix this, make the default position of the intermediate parent the same as the head. That way it doesn't move when it's suddenly constrained in pose mode. And now we have a switchable parent. Yay! However, this is going to be a bit of a pain for the animator. The constraint they need to change the influence on is a mechanism bone, which means it's normally going to be hidden. So we need another way for the animator to access the parent switching, preferably from directly on the iTarget control. Now, we could use a driver to drive the constraint influence using one of the unused transform channels of the iTarget, maybe one of the other scale axes. But that's not really intuitive at all. Instead, I'm going to introduce a new feature, custom properties. Custom properties are pretty much exactly what they sound like. Bones and objects have a bunch of built-in properties like their transform channels, but Blender also allows us to add our own for whatever devious purpose we like. To do this, go to the iTarget's bone properties. Down at the bottom, there's a panel called Custom Properties. Open it up. This is where we can add any custom properties we want to this bone. Click the Add button. The default custom property is a number property named Prop. To change this, click the Edit button. From here, we can change pretty much anything we want about the property. For starters, let's change the name of the property to something more descriptive, like follow head. Now, there are different kinds of content that a property can have. It can be a number, or it can be text. And even within numbers, it can be an integer, or a number that can have fractional components. The type of a property is determined by the default value you give it. So for example, if we type in some text, now the property is a text property. If, on the other hand, we enter a simple number, like 2, then the property is an integer. It can be any integer number, but if we try to enter a number with a fractional component, like 4.5, it ignores the fraction part. If we want to be able to have fractional numbers, then we need to put a decimal point in the default value, like 1.0, for example. In this case, we want a number that can be fractional, but we also want to limit the range of numbers it can be. If we edit the property again, we see that it has min and max fields. These fields define the smallest and largest number allowed in the property. In our case, we only want numbers between 0 and 1, since that's the range of the constraint's influence slider, so enter them into those fields. Lastly, if we want, we can even give the property a tooltip. Whatever we put in here will pop up when the mouse cursor hovers over our property. It can give a fuller description of what the property does. In this case, though, I think the property's name alone is descriptive enough, so let's confirm all of this. Click OK. Now the animator will be able to access any custom properties on the currently selected bone, under Properties in the End panel. Now we just need to make a driver for the constraint influence. Let's grab the RNA path of our custom property, since we're going to need it in a moment. Now go to the Copy Transforms constraint, and add a driver to its influence slider. And now let's go configure the driver. use the single property variable type, and paste the RNA path of our custom property into the path field. Now if we play around with the head bone and our new custom property, we can see it working. Yay! The animator now has convenient access to the parent switch. And that's it. We're done with the eyes.